Good evening, everyone. That was a great sharing from the platform engineer. So I'm now trying to bring some insight from the end user perspective. Okay, I would like to thank you, Mr. Saijie, for inviting us and give us a chance to share our practice of building a real-time analytics system of Pulsar and ScyllaDB. Okay, this is a little background. Yeah, nothing interesting. Yeah. Okay, so I'm Lei. I joined Proxy Data around middle of last year, and we are part of Tencent IEG Global. My role is a principal engineer and a security service team, which is overwatch a broad range of security risks for our business. So that is why we need to build a real-time analytics system or solutions to consistently monitor all kinds of activities that occurred in our business domain. So let's have a quick look at the overview of today's session. Okay, the session could be divided into two parts. The part one maybe sounds like a little bit theoretical, and part two we are focused on practice. So the part one we are going to address two questions: what are CQRS event sourcing, and what are the benefits of combining CQRS with event sourcing? Some of you may already heard this two terminology and very familiar with it, and some of you may just heard of this term at this moment. So I would like to give someone who may not very familiar with such concept a quick introduction and to build up some intuitive understanding of this architecture, and which I believe could help you better know why we go with CQRS and event sourcing instead of a stereotypical CRUD system. Okay, so sorry. And okay, this is part one. Okay, let's take a quick look at our stereotypical CRUD system. What does it look like? So to better understand the fundamental problem and challenges we are dealing with before we move on to CQRS and event sourcing, let's take a look at what a stereotypical architecture looks like. The above architecture is centered upon a backing data storage system, which is there's a cursor, okay, which is here. So this system is typically RDBMS, but it does not have to be. It could be as easy as a binary store or object database, or even a plain text file. Yeah. The important aspect of this storage is it is representing the current state of the object in a domain. I use the word domain to refer an area of a team focused on. For example, as a security service, we have several domains. We own several domains like anti-cheat, content moderating, and DevSecOps. They are different domains. So beneath the backing data storage lies a Apache server here, and which contains the business logic of the system. In this area, validation and orchestration logic exists for processing the request given to the application server. And it is important to know that this is an oversimplified architecture. And in a real-world system, there may have another pattern comes along with stereotypical approach. You may have a gateway in front of application, and a data layer between application and the data storage. Okay. This diagram is meant to show the idea of using application server to abstract away the data storage of a system and provide a centralized location of business logic. This idea has become very popular, extremely popular over the years. It is, in many circumstances, considered to be the default architecture that apply to many systems. So, and also many tools have been invented around this architecture to increase the developers' productivity. And I believe maybe everyone in this room, including myself, have been working on a similar system, yeah, during some time in our career. And from architecture perspective, I would emphasize three important properties. One is simple and straightforward. yeah, it's really obvious. And I would say any pattern system becomes popular, it must be simple enough to understand. And in this architecture, domain models and DTOs, which is part of API contract, designed by developer, the developer application, and in light of functional requirements, clients, in our perspective, clients in production team, clients and customers adhere to the contract defined by the function team. And the whole system is pivoting on states. Yes, object is a collection of states. You can call states different names, depends on which programming language you are using. Yeah, like Python call them attributes or properties, Golang call them fields. But eventually all of them are states. The reason I say this approach pivoting on states is that the backend storage most likely only keeps current state. And we usually have objects first and then figure out the transaction and actions later. And by looking at your database schema, you probably have no idea what action is going to take on a particular object. And by the way, from aspects of team collaboration, yeah, usually we have three kinds of team, which is function team, graphic team, platform team, and each of them will appear within this object. And to be clear, I'm not trying to say this actor is bad. Yeah, I'm not trying to say that. So if a simple curve system is sufficient, you definitely should go with it. Okay, so we can start dive into the CQRS. Okay, so let's take a look at what is CQRS. CQRS stands for Command Query Responsibility Segregation. Greg Young coined this term in his CQRS document, according and
somebody on Zoom said like the voice is low. You can
okay.
a little bit.
Okay. So okay. So according to his document, CQRS originated from Bertrand Meyer. This is actually a French name. I'm not sure I pronounced it right. And command and query separation principles. Wikipedia defines the principle as, I quote, that every method should either be a command that performs an action or a query that returns data to the caller, but not both. In other words, asking a question should not change the answer. And more formally, methods should return a value only if they are referential, transparent, and hence causes no side effects. And CQRS was originally considered just to extension to the CQRS principles at a higher level. But eventually, after much confusion between the two concepts, they were finally deemed into different patterns. And the CQRS was use the exactly same definition of commands and queries that Meyer used. The fundamental difference is that in CQRS, objects are split into two categories, one containing commands and another containing queries. And the key idea here is to explicitly build data models that serve read and write respectively, instead of doing read-write against the same data model. So I found another simple definition of CQRS on Amanda's Bernate's blog. I quote, the command and query responsibility segregation pattern separates read and write operations from a data store. Read and write may take entirely different paths through the application and may be applied to a different data store. And CQRS relies on asynchronous replication to progressively apply writes to the read side view. So the changes to the application state instigated by the write are eventually observed by the reader. Quite long and a very descriptive definition. Okay, at this point, I hope you at least got some intuitive understanding of CQRS. And this pattern actually is not very interesting by itself. But however, it became extremely interesting when you're working together with event sourcing from an architecture point of view. Okay, this is event sourcing, also a very simple idea. The fundamental idea of event sourcing is that ensure every change to state of an application is captured in an event object. And the event objects are stored in the sequence that they were applied to the application state. So in another word, instead of just store the current state of the data in a domain, use an append-only install to record the full series, of action taken on that data. The idea is simple but really powerful, because even the store acts as a system of records and can be used to materialize the domain objects attributes. As the events represent every action has been recorded. So any possible model to describe this system can be built from the event. Yeah, I was trying to figure out who is the first person naming this pattern as event sourcing, but I didn't find it, because I think this idea is probably really old. So take your back statement that which is a real world example, good example of what is event sourcing. Okay, a simple summary of event sourcing is tracking changes by capture the sequence of actions instead of overwriting the states deconstructively, which what does a CRUD system usually does. Okay. Okay, next. This is finally we combine these two patterns together. So CQRS and the event sourcing become most interesting when combined, and because they have a symbolic relationships. CQRS allow event sourcing to be used as a data store mechanism, and the event sourcing is very important when building out a non-trivial CQRS-based system. Although you can maintain relation models, one for reading and another for writing, but if you really do so, this practice is quite costly, especially if you factor in there is eventually have an event model to synchronize to. And so the event model is also the persistence model on the right side, because the CQRS fundamentally split a system into two parts. One is for write, one is for read. So event sourcing, your event model naturally becomes the persistent model on the right side. But on the other hand, one of the large issues of using event sourcing alone is that you cannot ask a system a query such as give me all users whose first names are Joe. It is impossible. This is due to not having a representation of current states. The only valid query to a event sourcing system alone is get event by ID. So the responsibility of the maintaining current state shifted to the event processor, and the different processor can generate different views against the same events. Okay, before we conclude the part one, I would like to share a real world story, which I believe is a more tangible example to explain why we choose CQRS with event sourcing as our service architecture. Okay, this is a screenshot from the Tower of Fantasy. We just released this game recently. And user can open this dialog and file a report against another player, because so many reasons you can see. And we can imagine if we go with the stereotypical CRUD system, how would you like to keep those records to further action, and what problem we are going to see? Any volunteer to share your thoughts? Okay, as far as I can see, the first problem is which team gonna own this database to save this form? As you can see, different reasons if determines this case eventually handled by different function team. So no function team owns this form, fully own this form. So there's a you cannot simply, especially there is an option called others. So we don't have a team to handle other complaints. So it's for us, it's very nature to capture this case as an event, like report file, and all the information captured in this event and as is, and all function team just subscribe to this event and do their own filtering. So what if they think this case failed in their domain, they can just capture it and trigger the further action against this case. So I would say this architecture gave us a better team integration. So we can collaborate domains where many teams access the same data in parallel. And CQRS allows you to define commands with enough granularity to minimize the conflicts, merge conflicts at the domain level. And there are also different work habits. In the stereotypical CRUD architecture, function teams tend to work in their silo without too much concern if their API contract is friendly enough to the production team. We can fulfill this requirement. Why you don't like it? And in worst case, the same information will be passed to different functional teams in different ways because they have different designing style. But there's only one production team. So I hope oh, okay. There's another. Do go to this link. I can share your slides after this meeting, and do go to this link this page points out more scenario when you should consider using CQRS within sourcing, like business rule change regularly, etc. Right. Do follow this link and to do a further reading if you're interested in this topic. Okay, so part two. Any questions? Okay, part two. This part will be more practical, I would say. Okay, so before we move on to questions, why we build our system on top of Apache Pulsar, please allow me to spend a few minutes highlight some key features that distinguish Apache Pulsar from other solutions. Yeah, I would like to say these features are essentially for us to deciding to land our solution on top of it. The first architecture property is a very important one: storage and compute decoupled and node parity. So the first property actually give you a flexibility on you can independently scale your compute resource and the storage resource. If, for example, you do not need a very high throughput, but you want to keep your data for a longer period of time, you can just scale up, maybe scale up your Bookie cluster. And if you don't need to keep your data for a long time, but require a higher throughput, you just bring up more nodes. And we're not going to talk too much technical details here. So a second property is node parity, which means there's no master node. So usually it means you can scale your cluster much faster and easier, and also bring the fault tolerance, better fault tolerance. Okay, so this is one. Okay, this is regarding to features, multi-tenancy and workload isolation. So if you are going to run a Pulsar instance that's shared with a large organization, I think multi-tenancy is a must-have feature to isolate the workload of different departments. And within tenant, Pulsar also allows you further divide your workload by namespace. And another important geo-replication. So I think this picture could explain what the feature does by itself. I don't need to say too much. And but yeah, simply say consumer and producer in different clusters, usually geo-diversified, could have the same view of the event stream. Our topic, when I say event stream, is I refer to our topic. Okay, so I will show you how we leverage these two features to better govern our data. So if you only run a single cluster, maybe the data governance is not a big deal because all your data saved in a single cluster, which geolocationally you are within maybe a border of some or certain country. But if you, there are many reasons that will push you go beyond one single cluster deployment. I just list a few here, maybe align the RTO or RPOs of the organization, or lower network latency for better user experience, and or just for comply with regulations. For our case, our concern is the last two, the lower network latency and the regulation compliance. So let's quickly go through some typical approach when we're deploying a multi-cluster system. Okay, this one is copy to other regions. This one is just run multiple independent instances in different regions and with no interconnection. But sometimes you have to do it. For example, you deploy your solution to a customer's private data center. So it's an independent cluster. But the downside of this approach is the maintenance cost will surge when you deploy more and more clusters. But this approach do give you high level of confidence in compliance because there's no way you accidentally process a data or save a data in a wrong location. And this is another approach. We call it application level federation. So this approach is pushing the complexity to the application layer. So the application server will coordinate with other peers and make sure data has been saved at the right location. If your organization only runs one application and doesn't have a heterogeneous infrastructure, this approach probably makes sense because no matter how complex it is, you just have to done it once. And but for us, we have our organization actually have hundreds of applications, if not thousands. I didn't count it exactly. And ask every application developer to deal with multi-cluster challenge make less sense from our point of view. And in order to make our developer life much easier and worry less about complicated compliance issue, we finally go with another approach. We call it a global data rain. So I will explain later. So this is a combination between policy and the technology. So every application only has access to the local endpoints. For instance, the Pulsar, every cluster have a Pulsar instance and have a CRUD instance. And so between applications, there's no interconnectivity. So there's no way to accidentally gain access to a region it should not touch. And the platform team can enforce this policy without involving individual application developers. And we are using namespace as a geofencing data container. And basically there are three types of namespace currently we have. The one is global namespace. The global namespace actually is simply enable the geo-replication among all clusters. So application runs in different regions could share the same view to this kind of namespace. Any data write to the global namespace are automatically propagate to rest regions. And we have regional namespace. A regional namespace actually, we can call it local namespace, which that means we didn't enable geo-replication on this type of namespace. So we can sure the data will contain within the same region of the writer. So within some border of certain country. And another one is cross-region namespace. The difference between the cross-region namespace and the global namespace, cross-region namespace only enabled geo-replication on selected clusters. And the reason we have this type of namespace because some jurisdictions allow us to move data out of their border for further processing, as long as we keep our original copy inside the border. So this gives us a flexibility to move our workload around the near regions. And up to this point, the compliance policy actually could be represented by the system configuration of Pulsar and ScyllaDB, and which is fully under control of the platform. So, and those structured configurations are much easier to audit and do visualization, and which eventually help us build our better governance within our organization. Okay, takeaways. Depends on which team you are working on. You probably will try to build a materialized view for query next month. And next, if you are working, no matter you are working as a function team or production team, try to figure out the domain events the system can produce with your client. If you are a function team, your client is a production team. And within next year, try to implement your data model based on the domain events of your client, but not in the reverse order. And try to establish a global data way with the organization. That's all. Any questions?
Provided by Pulsar itself.
No. Yeah. Our unit processor will build the view and save it in the CRUD directly.
I see. So you have some like a scheduled pipeline job to run the.
Yeah.
I thought like Pulsar have something similar to KCL. Not yet.
KCL, not yet. Yeah. It's just I heard some experiments. Regarding to directly run circle search against the ledger. The bookie logs. Yeah. But it is still in early stage.
Okay.
Yeah.
Some question. Any questions? Any questions online? Oh, okay, please.
So can you go back to the global link?
Okay.
So I have questions. The first one is I want to make sure that the replication is eventually
consistent. Yes. Correct. Yeah.
And the second question is from my point of view, that's the application layer, you don't need to do anything, but the platform layer, there are lots of things to do. So why do you think that doing in the app platform layer is easier in the application?
Okay, so in this picture, you may think the application is nothing here, but the reality, we have hundreds of applications. For Pulsar and ScyllaDB, we just have a few.
Oh.
Yeah, your application, in every region, we have hundreds of applications running simultaneously. And actually, application does a lot of things that that are the platform team, because application will consistently consume the domain events and trying to maintain the current state depends on which function team they are working.
Okay,
for example,
so the main point here is we can have a multiple applications, but only have one ScyllaDB and one.
Oh yeah. All other applications share the same platform. Yeah,
I see.
We do not go with this architecture. So every application have its dedicated platform, which we think make less sense because the application is way more. The number of applications is way more larger than the number of platform we have.
Well, actually, there's a question online, and it's a very interesting question as well. I want to ask as well. So, what is the advantage of using Pulsar instead of using Kafka?
Okay. Okay. Pulsar. If you any experience the scale, if you scale out a Kafka cluster, you have to wait the the cluster became rebalance the data. And Pulsar take a different approach. So any node you add to your bookie cluster will instantly start contribute the throughput and the storage immediately. No, there's no time to how should I say? There's a no data rebalance stage. Yeah, this is the big advantage from our point of view. Yeah, we can make our platform more elastic.
Any more questions? Both from online or from offline?
Platform in the slide, is it like exact gateway or is like the main?
So sorry.
What is the platform inside the slide?
Okay, the platform here meaning the actually platform. The definition of platform may be different across different organizations. In our case, the platform is the team maintaining the Pulsar and ScyllaDB and combined with the underlying infrastructure like VPC, and they will doing VPC peering to establish this ring, something like that. And we'll manage the Kubernetes cluster for application to run, something like that. Yeah. The definition actually depends on the organization, how the organization works. But typically, I believe we have some similar structure in order to collaborate different teams.
Okay, any more questions? From local or from remote? All right.
Thank you.